Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be jumping into the machine learning course on Codecademy once again. In the previous video, we talked about Bayes' theorem. It's a pretty short video, so if you missed that, be sure to go check it out. Today we're going to continue into the Supervised Learning 2 module with the naive Bayes classifier. So I'm just going to hop right into it, nothing much else to talk about. A naive Bayes classifier is a supervised machine learning algorithm that leverages Bayes' theorem to make predictions and classification. Now recall, Bayes' theorem, like we discussed and used in the previous episode, is the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. This equation is finding the probability of A given B. This can be turned into a classifier if we replace the B with a data point and A with a class. For example, let's say we're trying to classify an email as either spam or not spam. We could calculate the probability of spam given that it's an email and probability of not spam given it's an email. Whichever probability is higher will be the classifier prediction. Naive Bayes classifiers are also used for text classification. So why is this a supervised machine learning algorithm? In order to compute the probabilities used in Bayes' theorem, we need to provide previous data points. For example, in the spam email, we'll need to compute probability of spam. This can be found by looking at the tag data set of emails and finding the ratio of spam to non-spam emails. All right. Investigate the data. In this lesson, we are going to create a naive Bayes classifier that can predict whether a review for a product is positive or negative. This type of classifier could be extremely useful for a company that is curious about the public reaction to a new product. Rather than reading thousands of reviews or tweets about the product, you could feed those documents into the naive Bayes classifier and instantly find out how many are positive and how many are negative. The dataset we will be using for this lesson contains Amazon product reviews for baby products. The original dataset contained many different features, including the reviewer's name, the date the review was made, and the overall score. We've removed many of those features, the features that were only interested in the text of this review, and whether the review was positive or negative. We labeled all reviews with a score less than 4 as a negative review. Note that in the next 2 lessons, we've imported a small percent of the data to help run the code faster. We'll import the full data set later when we put everything together. All right, let's look at the data set given to us. Print position list 1. If we do that at index 0 or at index 0 or the first spot, it's asking us, would you classify this as a positive or negative review? So let's take a peek what it says. Perfect for new parents. We were able to keep track of the baby's feeding, sleep, and diaper change schedule for the first 2.5 months of her life. Made it easier when the doctor would ask about habits because we had it all right there. So that definitely seems like a positive review. Now we're going to take a look at the first review in the negative list. I assume that it's, neg list 0. If we quickly... this is fine. Starts here. So it says, I wanted to love this, but it was pretty expensive for only a few months of a calendar pages. I ended up buying a regular weekly planner, 55% off the planner that is 8 by 12 or 8.5 by 11. Had all 7 days on the right page. The left page had a lot of room to write to-do lists and goals. I found this more helpful because I could mark each day's eating and sleeping blocks, then also side by side. I could also see the planner was cute, just not what I wanted. So obviously a negative review. All right, we've also created a counter object for all positive reviews and one for all negative reviews. These counters are like Python dictionaries. You could find the number of times the word baby was used in the positive reviews by printing position. I guess we'll print position or positive, counter at the word at the word baby. And we'll see that baby was used 33 times in all the reviews. Now it wants us to try crib instead. If we type crib, we see crib was only actually ever used 1 time. And the negative. So we can do this. We'll just quickly copy and paste this. Well, it looks like in the positive reviews, it's only mentioned 1 time. In the negative reviews, though, it's mentioned double-digit 12 times. All right, Bayes' theorem 1. For the rest of this lesson, we're going to write a classifier that can predict whether the review, this crib was amazing, is a positive or negative review. We want to compute both probability positive given a review and probability negative given a review, which is the probability, and find which probability is larger. To do this, we'll be using Bayes' theorem. Let's take a look at Bayes' theorem for positive review. We're going to say that we're trying to find the probability that given there is a review, what is the probability that it'll be positive? We set that equal, or that is equal to the probability that it is a review given that it is a positive review, and times the probability of positive divided by the probability of a review. The first part of Bayes' theorem that we're going to tackle is the probability of positive. This is the probability that any review is positive. To find this, we need to look at all of our reviews in the data set, both positive and negative, and find the percentage of reviews that are positive. We bolded the part of Bayes' theorem that we're working on. Okay, so find the total number of reviews by finding the length of positive lists. So we can do that by printing length of positive list. I'm going to set that equal to A. Now I'm going to set this equal to B, and I'm going to print, or I'm going to just set, I guess I shouldn't do print. A is equal to length of positive list, B is equal to length of negative list, and then finally we can say total reviews is equal to A plus B. Cool. Now create variables named percentage positive, percentage negative. Percentage positive should be the number of reviews divided by total reviews, right? So we can say percent positive is going to be equal to A divided by total reviews, and percentage negative is equal to B divided by total reviews. All right, let's print them. We can see it's literally 50-50. I did print both percent positive and percent negative. Did I spell something wrong? Maybe it's because they're in, this would be stupid, but it might be because they're in the same print statement. That's stupid. So, yep, they're both 50-50. About half of the reviews are positive, half are negative. All right, Bayes' theorem 2. Let's continue to try to classify this review. The crib was amazing. The second part of the Bayes' theorem is a bit more extensive. We want to compute the probability of a review given that it is a positive review. In other words, if we assume that the only review is positive, what is the probability that this crib was amazing are the only words in the review? That's interesting. Okay, so it's not what I thought it was originally. We're saying that the review is actually just the words. So, okay. Because I was going to say it was probably just 100%. It's asking what is the probability of a review given it's a positive review. In other words, if we assume that the review is positive, what are the probability that the words this crib was and amazing are the only words in the review? To find this, we have to assume that each word is conditionally independent. This means that one word appearing does not affect the probability of another word showing up. This is a pretty big assumption, obviously. We now have this equation. We can scroll to the right to see the full equation, obviously. Let's break it down even further by looking at one of those terms. Crib is the probability that the word crib appears in a positive review. To find this, we need to count up the total number of times cribs appeared in the data set. If we take the total number and divide it by we'll end up with the probability. Okay. Let's first find the total number of words in all positive or roos and store that in. Yeah, okay. So we're saying total positive, and we're setting that equal to sum function. Takes a list as a parameter. The list that you want to do is the values of the dictionary, which you can get, yeah. So post counter dot values, and we'll do the same. Total negative is equal to the sum of negative counter dot values. Cool. Okay, now we have the total number of words in positive, total number of words in negative. So now we're going to create two variables named positive probability and negative probability. Each of these variables should start at 1. These variables are going to keep track of the probabilities. So we're just going to, for right now, set them equal to 1, right? And set it equal to 1. Just set them equal to 1 to start off. And now we're going to create a list of the words in review. So what we can do, we'll say review words. I'm going to do, they probably do some sort of list comprehension. What I'm going to do is a for loop. So for word in review, I'm going to say, well, let's see what happens when I print review first, just to see. When I print review, it prints out every letter. Split function. So we want to do first the dot split, that makes sense. Split function. Now what happens when we print word? When we print word, now they're separate. So now what we can do is do review words dot append with word. Okay, cool. Now we're going to loop through every word in review words and find the number of time. So now we're going to loop through every word. So we've created review words. So we can exit this for loop. This for loop has done its job. We're going to loop through every word in review words. Find the number of times the word appears in position or positive counter and negative counter. Store those values in a variable named word in POS and word in negative. Loop through every word in reviews. So for word in review words, it wants me to find the number of time this word appears in positive counter and negative counter. Word in positive is equal to the dictionary of, what is that dictionary called again? Pause counter, word in negative is equal to counter with the word. I'm confused because this isn't going to be right, I don't think. That is right, okay. That's fine. Inside the, okay, yeah, so we are going to be doing the same thing. Pause probability is equal to word in pause. Well, did we? Okay, word in pause divided by total positive neg probability is equal to word in negative divided by total neg, right? Yeah. This step is finding the term. Yeah, right. See if I'm getting this second for loop correct here. What are we doing here? What is this star doing? I have to actually look this up really quick. Oh. I see. So it wants me to multiply it. So we do that makes sense. Okay, they're both really small, obviously. It looks like the positive probability is a little bit higher. But I see now how this is working. So let's go through it just so I know for a fact I understand what's happening here. We have our initial review, which is this crib is amazing. We found that the percentage of positive reviews was 50%, making the percentage of all negative reviews in our data set 50% as well. We took the total number of words in the positive reviews and put them here. This is just every single word that ever appeared in a positive review. And this is obviously the opposite, every single word that appeared in a negative review. We initialized the positive probability at 1 or 100%, as well as the negative probability at 100%. We then found the words. This was the very simple. We're just actually looking at the words that are in the review. We split it up using the .split command and appending it to the dictionary, right? Finally, in this last for loop, we loop through those words that are in the review. And for each word, we find the word in positive, which is just how many times that specific word was found in all positive reviews. And we did the same thing for the negatives. Then we found the positive probability, which was multiplying. We multiply positive probability of 1 times the word in the amount of times it was there divided by all of them, right? So the total positive words. Found that and multiplied it. And then we did negative and we did the same thing. We printed it out. Okay, I'm definitely following. So, smoothing. In the last exercise, one of the probabilities that we computed was the following. Probability that the word crib appears in a positive review. What happens if crib was never in any of the positive reviews in our data set? This fraction would be 0, and since everything is multiplied together, the entire probability would become 0. This is essentially problematic if there are typos in the reviews which we are trying to classify. If the unclassified review has a typo in it, it is very unlikely that the same typo will be in the data set, and the entire probability will be 0. To solve this problem, we use a technique called smoothing. In this case, we will smooth by adding 1 to the numerator of each probability and n to the denominator of each probability. N is the number of unique words in our review data set. For example, probability of crib positive goes from this to this. Let's demonstrate how these probabilities break if there's a word that never appears. Let's change review to this crib was amazing. Notice the second B. If we add this, it's a typo, obviously, and both probabilities go to 0. Obviously not something that we want. Now inside our for loop, when you multiply positive probability and negative probability by a fraction, add 1 to the numerator. So we can do that by doing plus 1, plus 1. Oh, and I didn't add, oops, I didn't add parentheses like a dummy. Now we get an actual probability. And then in the denominator of those fractions, add the unique number of words that appear in the data set. For this positive probability, it should be just the length of it, which we can found. So we're going to, in this bottom one, again, we'll add some parentheses, but we're going to add the length of positive counter. And in this one, we'll also throw it in some parentheses and then add the length of negative counter. Did smoothing fix the problem? Obviously, yes, it did. We don't have zeros anymore, which is obviously exactly what we want. All right, class 5. We look back to Bayes' theorem. We now have completed both parts of the numerator. We now just need to multiply those together. And now let's consider the denominator, probability of review. In our small example, this probability that this crib was and amazing are the only words in the review. Notice how that is extremely similar to probability of review given positive. The only difference is that we don't assume that the review is always positive. However, before we start to compute the denominator, let's think about what our ultimate question is. We want to predict whether the review, this crib was amazing, is a positive or negative review. In other words, we are asking whether probability of positive given the review words is greater than the probability of negative given the review words. If we expand those two probabilities, we end up with the following, right? Probability of negative, right? Notice that probability of review is the denominator of each. That is the value that will be the same in both cases. Since we're only interested in comparing these two probabilities, there's no reason why we need to divide them by the same value. We can completely ignore the denominator. Let's see if our review is more likely positive or negative. So, after the for loop, we want to multiply we want to multiply positive probability by percent positive, and final negative is going to be just the opposite, negative probability times percent negative. And I didn't print them, which is fine. We can do that final positive, and we'll do separate print statement, even though that shouldn't be necessary. Compare them if final is greater. Let's see. So we got our two probabilities. It wants us to now print a statement depending on what we believe is higher. I haven't quite taken a peek at it, but let's look now. So it appears they're both times e to the negative 3, so we're really just going to be looking at this. And obviously, the final positive is a bit bigger. So we're going to say that the review is positive. That is correct. The naive Bayes classifier did get it right. Obviously, this crib was amazing is a good review. Now let's replace the review, this crib was amazing, with one you should be thinking is negative. This crib was horrible. Was not good. This time they're much closer, but the negative is also still all right, cool. All right, formatting the data for Scikit-learn. Congratulations, you made your own naive Bayes text classifier. If you have a data set of text that has been tagged with different classes, you can give your classifier a brand new document and it will predict what class belongs to. We're now going to look at how Python Scikit-learn library can do all of the work for us. In order to use Scikit-learn's naive classifier, naive Bayes classifier, we need to first transform our data into a format that Scikit-learn can use. We're going to do that, we're going to use Scikit-learn's count vectorizer object. To begin, we need to create a count vectorizer and teach it the vocabulary of the training set. This is done by calling the fit method. For example, in the code below, we've created a count vectorizer that has been trained on the vocabulary training, review, 1, and second. After fitting the vectorizer, we can now call its .transform method. The .transform method takes a list of strings and will transform the strings into counts of the trained words. Take a look at the code below. Counts now stores the array 1, 2, 0, 0. The word review appears twice. The word 1 appears once, and neither training nor second appear at all. But how do we know that the 2 corresponds to review? Well, you can print vectorizer.vocabulary to see the index that each word corresponds to. It might look something like this. Finally, notice that even though the word 2 was in our new review, there wasn't an index for it in the vocabulary. This is because 2 wasn't in any of the strings used in the .fit method. We can now use counts as input to our naive Bayes classifier. Note that that in the code editor, we've imported only a small percent of our review data set and make load times faster. We'll import the full data set later when we put all the pieces together. All right, let's create a object. We'll call it counter and set it equal to count vectorizer. We're going to call counter's fit method. To do that, we're going to put a string into it. Okay, so we'll do that. We'll do counter.fit using the negative list plus positive list. We'll now print vocabulary underscore. And I didn't print it, so we can
narrator dialog.
Oh.
Narrator window heading level 1. Welcome to narrator. This is narrator home,
Okay.
where you can supervise. Heading level 1. Scan off. Code editor region. You are currently inside script.
How did I
new
mess
tab.
this up?
Google
How to
space.
turn off narrator in Windows 11.
Scan. Accessibility links link. Skip to main content link. Banner link.
Windows.
Skip to content. Exiting narrator.
Okay, that's how I did it. Sorry about that, guys. Oh my goodness, that's super embarrassing. But I do that a lot, where I'm accidentally, pressing maybe Control. Well, now we know if it ever happens again. We can now see the entire list of all the different words that are inside of this data set, right? So wife appears 1,561 times, maybe a very important word. This appears that many times. Wanted appears that many times. So a lot of times. Let's transform our brand new review, create a variable name review counts. We're going to set this variable equal to counters.transform function. So we can do counter.transform. And inside the .transform, we're using review as a parameter because we've already set review to this crib is amazing. We can now click that, and we want to print review counts dot to array. I am going to quickly hide this because we don't want to see all that. It looks like we see a big list of zeros. Looks like this is an array of all zeros, but the indices should correspond to the words should all be 1. Let's use review counts as the test point for our Bayes naive classifier, but we also need to transform. Our training set is negative list plus positive list. Call transform using that parameter. Store the results in a variable named training counts. Okay. See what I'm doing wrong here. Interesting. Oh my fucking god. Cool. Alright, using scikit-learn. Now that we formatted our data correctly, we can use scikit-learn's multi-nominal NB classifier. This classifier can be trained using the .fit method. .fit takes in two parameters, the array of data points, which we just made, and an array of labels corresponding to each data point. Finally, once the model has been trained, we can use the .predict method to predict the labels of the new points. Predict takes in a list of points that we want to classify and returns the predicted label of those points. Finally, .predict underscore prob A will return the probability of a given label at a given point A. Instead of just returning whether the label is good or bad, it will return the likelihood of a good or bad review. Note that in the code editor, we've imported some of the variables you created last time. Specifically, we imported the counter object, training counts, and the review counts. This means the program won't have to recreate those variables and should help the runtime of your program. Okay, so begin by making a classifier using the object multi-nominal NB. I assume that doesn't take any parameters, so we'll just do that. In the second step, it wants us to fit the classifier. We've transformed the points found in training counts, but we don't have the labels associated with those points. We made a training points by combining negative lists and positive lists, so the first half of the labels should be 0 for negative and second half should be 1 for positive. Create a list named training labels that has 1,000 zeros followed by 1,000 ones. Note that there are 1,000 negative and 1,000 positive reviews. Normally you could fit this out by in this example we haven't included. So it wants a list named training labels. I'm going to again do this using a for loop. So I'm going to say for I in range 1 through 1001 training print I. Let me just do that really quick. Yes. 1 through 1,000, perfect. So what I will do is print training labels dot append with a 0. Then I'm going to make a second one for I in range 1 through 1001 training labels dot append 1. Is that what it wants us to do? Cool. All right. Call classifier's fit function. Take two parameters, the training set and the training labels. So we can do that by doing make sure it's not in the for loop. Classifier dot fit. The first parameter is the training set. So we can call training counts and then training labels. We can now do classifiers dot predict method. This method takes in a list of points that you want to test. Review. Let's see what it wants us to actually do. Your test points are found in the variable. So predict method. This method takes a list of points that you want to test. Was your review? So I'm a little confused on if we want to put review counts in there. Is that actually what we're doing? Yep, we're putting review counts. Not review for some reason. So we just don't ever use review. It's just here as a red herring, I guess. Review counts. This is not what I'm done. I want it just to be printed out. One, after printing predict, print a call to the prob A method. The parameter should be the same as predict. The first number in the printed was okay, so we're just going to print the classifier function prob, or it's predict prob A of review counts. Classifier. Cool. Change the text review to see the probabilities change. So it's, I see. The first number printed is the probability that the review was a bad review, and the second is that it's a good review. So it's saying it's a 77% chance that it's based on our data that it's a positive review. Okay, change the text in review. I guess we can do this by doing this crib was terrible. Much higher chance that it's a negative review, right? Cool. All right, review. In this lesson, we learned how to use and leverage Bayes' theorem to create a supervised learning algorithm. Here are some of the major takeaways from the lesson. A tagged dataset is necessary to calculate the probability used in Bayes' theorem. In this example, the features in our dataset are the words used in product review in order to apply Bayes' theorem. We assume that these features are independent. Using Bayes' theorem, we can find the probability of class given a data point for every possible class. In this example, there are two classes, positive and negative. The class with the highest probability will be the algorithm's prediction. Some other stuff, obviously, we did. In the code editor, we've included 3 naive Bayes classifiers that have been trained on different data sets. Try changing review and see how they react. This game was amazing. Baby training set. I see. Gotcha. All right, up next, we have a quiz. Given the following word counts for positive and negative reviews, what is the probability of great? So the probability of great is just going to be the probability that the word great appears divided by all the other words, right? So if we add these all up, we get 2 plus 1 is 3, plus 3 is 6, plus 2 is 8, plus 1 is 9, plus 7 is 16, and it looks like 20 in total. So it looks like it's 3 in 20. Which is 0.15. Nice. What is why is naive Bayes classifier a supervised learning? It learns from unlabeled data. You need labeled data, right? That's why it's supervised. Why can we ignore the denominator of Bayes' theorem when calculating probabilities of each class? The denominator is the same. Yeah, it's the same. If the target names of a naive Bayes classifier are B, A, D, and C, the predict prob A function returns a list. For a given data point, what is the predicted class for the data point? Oh, it's going to predict that it's D. Yep. Which of the following is not a natural language processing technique that can improve performance of a naive Bayes classifier? Smoothing is an important part. It has nothing to do with natural language processing. I was going to say it's the only one we talked about. So, what is the purpose of smoothing in a naive Bayes classifier? To prevent the feature with a probability of 0 from ruining the entire probability. Given the total word counts for positive and negative reviews, what is the probability of the word great given that it is a positive review? So to do this, we'll sum all of the total positive reviews. If we do 2 plus 1, that's 3, plus 3 is 6, plus 2 is 8. So it looks like it's 2 and 8. That's about a 25% chance, so I'll say that. The dot predict method in the multinomial NB class takes blank as a parameter and returns what? So it'll take a list of data points and return a single classification. Oh, list of classifications. It will turn run for each data point you give it. Okay, that makes sense. One wrong, a little bit of a mistake there right at the end. So just make sure. Let's read this out just so we know where we messed up there. So the dot predict method in the multinomial class takes a list of data points as a parameter and returns a list of classifications. The classifier provides a classification for each data point, resulting in an output of a list of classifications. Boom, data science. Boom, machine learning. And it looks like we have a bit of a project, which I'm pretty excited about. There seems to be, after this, something with vector machines. So that'll probably be next video, but we can do this thing. I'm pretty excited about this. Looks like we're going to be doing the sklearn or scikit-learn. So let's get into it. We've imported a data set of emails from scikit-learn's data sets. All these emails are tagged based on their content. Print email. Print emails target names to see the different categories. We do this. Still loading. Okay. So a lot of different stuff that is in here in the emails. A lot of different interesting stuff, motorcycles, autos, for sale. Okay, I am gonna hide that now. We're interested in seeing how effective our naive Bayes classifier is telling the difference between a baseball email and a hockey email. We can select the categories of articles we want to from fetch_20 news group by adding the parameter categories. In the function call, set categories equal to the list. Okay, so we'll set categories equal to a list. First one in the list is going to be rec.sport.baseball. And the second item in the list will be rec.sport.hockey. Cool. Let's take a look at one of these emails. All the emails are stored in a list called emails.data. Print the email at index 5. So print emails.data at index 5. Okay, so the email is in regards to the shuttle launch question, and it's in the Smithsonian Astrophysical Observatory. Just an email from Jonathan to, it looks like some guy named Tom, possibly. All right, all the labels can be found in the email, the label of the email index at 5. So instead, it wants me to print out target names at index 5. And does it say it's a baseball or a hockey? It says it's a compsystem.mac.hardware one. So where are we getting something wrong here? I see. We were supposed to do some sort of function call. We can select the categories we want from. I see. So we're going to say emails is equal to fetch underscore 20 news groups with this as a parameter. Now it should say hockey or baseball. Line 11. Rec.sport.baseball. Fetch underscore 20 news groups. Emails. I see. So we just want to add maybe this. Index is out of range. That's the issue. I'm a little interested on what I'm doing wrong. I didn't think I was doing much wrong. That seemed to make it not happy. See, now I'm confused because when I print out target, it's not going to let me. Okay. Okay, so now it's taken all the emails that are classified as a baseball or a hockey email, right? So now if we do target, it says 1. Okay, there we go. All right, a little bit of a stumble there, but I think we should be okay. We now want to split our data into training and test sites. Change the name of your variable from emails to train emails. So we're going to say that this is the train emails and add these 3 parameters to the function call. So we'll also add the fact that subset is equal to train. We'll add that shuffle is equal to true. And we'll add that random state is equal to 108. Adding the random, yep, so data split the same way. So now, yeah, I'm gonna hide that now. All right, we're gonna create another variable called test emails and set it equal to fetch underscore 20 news groups. The parameter of the function should be the exact same, except subset should be now test. So we can just grab all of that, Control C, Control V, and then instead of train, it should be test. Counting words. We want to transform these email to a list of word counts. The count vectorizer class, create a count vectorizer object. We can do that by making counter equal to count vectorizer object. That's that. We'll need to tell counter what possible words can exist in our emails. Counter has a .fit function. Yep, so we can do counter.fit with test emails.data plus train emails.data as a parameter. We can now make a list of the words of the counts of our words in our training set. Create a variable called train count. Set it equal to the counters.transform function. Using train underscore email data as a parameter. Test counts as well. Going to be very similar to train counts. Obviously, we're going to use the counter object transform. But obviously, we're going to use test emails.data. All right, let's make the naive Bayes classifier. Now let's make a naive Bayes classifier that we can train and test on. Create a multinomial NB object called classifier. We already have imported that, so we can now just do classifier is equal to multinomial NB object. Call the fit function. We can do classifier.fit. The fit takes two parameters, should be our training set, which is for us train counts. And the second should be the labels. And we can do that with train emails.target. We can now print the classifiers dot score function, the test set. So we'll put in test counts. It says score takes a test set and the test labels. Oops. So test, and then it would be test emails dot target as well. And now it should tell us that, wow, it was 97% accurate. So that was the accuracy. So that's pretty good for this. So now it says testing other data sets. Our classifier does a pretty good job at distinguishing between soccer emails and hockey emails, but let's see how it does with emails about really different topics. Click where you can find train emails and test emails. Change the categories to be that and that. Did the classifier do better or worse? So instead of baseball, it wants us to do IBM hardware, right? It's a little bit more of a difference, so maybe it'll do better. So we've switched them now. Let's see what happens. Oh. Huh. Whatever, I know we did it right. So for some reason it's saying it's not in the index, and it's not because of a spelling error, so I don't know why. I don't want to mess with that. I think that is going to be it for this video, though. Yep, we're going to be going on to a different topic in the next video, so vector machines. So if you did enjoy this video, please be sure to give it a like and subscribe, and I will see you in the next one. Peace out.